Hi, this is Dylan Sieverts on the 17th of January doing check-in number 2. Time spent studying, about 6 hours. Yesterday I spent 3 hours doing homework and watching videos simultaneously. I was in a study group with Charles Kane and we did the homework, problems 3 through 3 through 13. 3 through 12 is what we accomplished. So, let's see. Other efforts. Okay. So to summarize what I learned, is on number 3 and 4, they're very similar. I rewrote my acceleration and velocity functions in terms of dv dt and dx dt, or in other words, it's just the derivative of the position function in respect to time or the velocity function in respect to time. I got like terms on each side of the equation. I integrated that. However, I first needed to find one of my my values of integration. So I was able to do that, plug those in, and solve for my initial velocity. And then I plugged that back in after I found my time. And then I did the same thing, took the derivative of the velocity function, because it gave us originally the acceleration function. Got velocity function, took the derivative of that, and then integrated with a different x value, and ultimately I need to finish that one on number 3, but number 4 is the same. Just had to find different x and t values and plug those into your integration. Number 5, this was kinematic equation with circular motion. Basically, same thing, rewrote the acceleration function in terms of the derivative notation, reorganized that, integrated, plugged in values. That was number 5. Number 6 was pretty confusing, but ultimately found out how to do it. I wrote an equation with my unknown k equals xa plus 3 times yb, because there were 3 different pulleys. I took the derivative of that and plugged in all of my known values to ultimately get the velocity or change in acceleration and change in velocity and how far the handle actually moved. But that one was pretty straightforward. Number 14 is similar to that. I have not done 14. Number 7, we had to convert everything to meters or meters per second, and I had to use 2 different kinematic equations. I used the one that did not include gravity, that did not include distance, and was able to find time during either section 1, 2, or 3 of his free fall or descending to the earth. And once I found my t values, I would then plug that back into the other kinematic equation with constant acceleration. that was the key, is finding the kinematic values or equations there with constant acceleration, and was able to find the acceleration and at each point of his free fall. Or number 8, I need to finish. Basically, I integrated I, j, and k of the vector separately, and, or not integrated, but took the derivative, and it takes a lot to write that out. That's straightforward. Number 9, this one I used 2 different kinematic equations. It was very similar to, let's see, number 3 and number 4. Used one kinematic equation, plugged everything in with my x and y component of the vector, the person throwing it, and found my time at that moment, plugged it into the other kinematic equation that takes account for all the knowns, and I was able to find my y distance at in the middle at the very peak of the parabola or the pitch, and then at the batter height as well, dependent upon the x distance. Number 10 was the same thing, just a bit more complicated. Number 11 and 12 were similar. I used the kinematic equation for circular motion and times it by the amount of g's, gravity times the amount of g's they experienced, and solved for the unknown. Number 13, I do have to finish. I'm kind of confused on this one. Number 14, I assume will be similar to number 3, I believe. Or let's see, number 6. But yeah, I already went over. The videos that we watched was E3 through 9 and N through 9. And then some of the other random ones, like that are just on the landing page. And I think that is all. And yeah.